All right, finally the last section, 8 and 9. Here we're going to be talking about perfect squares. That's kind of like over here, where was that a plus b squared, and then you had to write it down twice, and then we foiled it, or we figured out that there was kind of a shortcut way that you could do that. So what I want to, this is kind of the key that you can use to know how to do this. Of course, I'll do some examples here. But I'm going to start down here on some of the easier examples before we go back up. For some reason, these are in opposite order of easiness. So what I'm going to look at here is, for a second, I'm just going to pretend like this doesn't equal 0, so I'm just going to ignore that. Goodbye. And I'm going to factor this. Now, here's the thing. I'm going to try this, even though I could totally do this with adding to 12, multiplying to 36. What number is that? I kind of want to get in the habit of maybe using a shortcut here. What I notice is that this is a perfect square. That would just be a. And this is a perfect square. That would just be 6. So look at the middle number. Does it equal 2 times this times this? Which in this case it would be a and 6. Well, 2 times 6 is 12, so 12a. The answer is yes. That means that this one is a perfect square. Let's write that. Perfect. Whoops. Perfect square. Yay! All right, so what that means I'm going to do is that this can be kind of shortcutted to just a, the square root of this part, plus the square root of this part, and I'm going to put plus because it was a plus sign here, 6 quantity squared. That's the shortcut. How does that work? Well, check this out. If I have, let's erase some of this stuff. If I want to do it the old-fashioned long way, I would say, well, what adds to 12 and what multiplies to 36? Oh, actually, that's just 6 and 6. So it would be x plus 6 and x plus 6. Oh, but anytime you have something multiplied by itself, that just becomes, you can write it once and put a squared. Oh, except they weren't x's, were they? They should have been a's. Is that not the exact same thing? But I want you to get in the habit of trying to think about this from a shortcut point of view, because in Chapter 9, you're going to need it. So try another one with me. 3b. This one's a little more complicated because of the fractions, but I do, anytime that it's just the variable squared, that's always so nice, because that is just going to be, a square root and happy nice right there. This, believe it or not, if I try it in my calculator, this is a nice happy square root of 2/3. So I think there's a good opportunity that this might be y, since it's a minus sign, it would be minus 2/3. Erase that there. Quantity squared, but before I box that and say, yes, that is my answer, I want to double check. Is this the same as 2 times the square root of this part, which would be y, and the square root of this part, which would be 2/3? And that looks like it would be 4/3 y. Because it's negative, it means that it must have been a negative 2/3. So it's just y minus 2/3 squared. Okay? To make a more complicated one, check out 1a. Here, the reason it's more complicated is because it's not just a happy y squared. It's got a 9. But that is a nice happy square root. That's just 3y. And this is a happy square root. It's just 4. So does this term equal 2 times these two things? 2 times 3 is 6. 6 times 4 is 24. Tack on the y. Yes. So the answer is 3y, since it's a plus sign, 4 squared. Now, why is this going to be useful? Later, you're going to want to solve these. This one's kind of already set up at this point. Up here, it was equaling 0. Here is where it won't have to necessarily equal 0, which will be super handy. And what we're looking at then is you can just square root to get rid of that squared. And that would just be a minus 10 equals square root of 121 is 11. This time you're only going to have one answer instead of two like in the previous ones. Okay, later in chapter 9 you're going to have to know how to do that. So, all right, that's it.